Hello everybody. Today we're going to talk about dividing integers. So luckily for us, we just did multiplying integers. So the sign rules for multiplying and dividing are exactly the same. And by the way, before we start, a couple things I want to talk about though, before we start talking about the sign rules. So with division, we have this symbol. Give me 1 second. There we go. We have that symbol. All right, and that's called the obulus. So I probably haven't heard that name too much, but that's the obulus. That's the division symbol you're probably used to seeing, but typically in algebra, we just use a fraction, okay? So just so you're aware of that. And also the parts to a division problem. So let's say we're dividing 9 by 3, and they're both positive numbers. Well, that equals 3, all right? But we have our dividend in the numerator. We have our divisor in the denominator. And our answer is called the quotient. So there are your parts to a division problem, okay? The divisor is what you're dividing the first number by, the dividend, okay? Your answer is the quotient. So there's your parts to a division problem. And again, this symbol is called an obulus. So that maybe could be an extra credit problem for you. That's called an obulus. So as we mentioned at the beginning, for our sign rules for division, they're the same as multiplication. So if you know your sign rules for multiplication, you know your sign rules for division. So let me clear this off here. So for our sign rules for division, we have a negative divided by a negative. That's going to be positive. Also a positive divided by a positive is positive. So again, just like multiplication, if your two numbers have the same sign, when you're dividing, your answer is going to be positive. And finally, if we have a negative being divided by a positive, or a positive divided by a negative, that's going to be negative. So if one of your numbers, the dividend or divisor, is negative, that makes your overall answer negative. Okay? Now, division is not as easy as multiplication because even though multiplication and division are inverse operations, division is not commutative. So the order is very, very important. So we'll talk about that later. But first, let's start with some basic sign rule facts. So let's say we have negative 64 divided by 8. Well, 64 divided by 8 is 8. Make our final answer negative because one of the numbers is negative. Or if we have a negative 25 divided by a negative 5. Well, 25 divided by 5 is 5. But we keep that positive because it's a negative divided by a negative. So if our two numbers have the same sign, that makes our final answer positive. Now, sometimes you might have to write it out depending upon the problem. Don't be afraid to write it out if you need to. So what I mean by that is, let's say we have a negative 168 divided by 12. Well, you might have to write that out. So if we do, we make our division sign, put our dividend underneath the division sign. Our divisor goes on the outside. I won't worry about the sign. Divisor is our second number. So 12 goes into 16 one time. Multiply there. Put it there. Subtract, we get 4. Bring down our next number, 8. And then 12 goes into 48 4 times with no remainder. So our answer is 14, but a negative divided by a positive is negative. So if you need to, with the division problem, you only have to write it out. Okay? Now, there's some things you have to be careful with division. So let's talk about dividing by 1. Dividing by 1 is not that bad. So if we have 20 divided by negative 1, well, 20 divided by 1, any number divided by 1 is just that number. So we have a positive divided by negative, so that's negative. Okay? So dividing by 1 gives you the same number back. Okay? Now, if it's 1 divided by a number, that gets a little tricky. So let's say we have 1 divided by 9, and now we'll actually get to more of an algebraic way of writing it, 1 over 9. Well, 9 cannot go into 1, okay? So you cannot take one thing and make a group of 9 things. So the best way to leave this is 1/9, okay? And we'll get more into those type of problems in a little bit. If your denominator can't go into your numerator, the best thing to do is to simplify or reduce it, okay? And the title of that should be involving 1, but you get the idea. 0. So let's say we have 0 divided by 7. That's going to be 0. If 0 is your first number, or I could also write this problem like this, if 0 is in the numerator, your final answer is always 0. Okay? It doesn't matter what number I have. Let's say I have 0 divided by 10,321. Doesn't matter. Maybe I'll make that a negative 10,321. So 0 divided by negative 10,321, guess what? The answer is 0. If 0 is in your numerator, or is the first number in your problem, that makes your final answer 0. Now, it changes if we're dividing by 0. So let's say we have 9 divided by 0. Okay? Well, in mathematics, you cannot divide by 0. So we call this undefined. Okay? So you cannot divide by 0 or have 0 in your denominator or second in your division problem. Okay? You cannot divide by 0 in math. So just to show you the difference again, 0 divided by 7 is 0. But any number divided by 0, or written like this, that is called undefined. You can't do it. And that has a lot of implications in mathematics for a lot of different, not just basic operations, but a lot of different functions, graphing functions. It has a lot of implications. Okay? Now, let's go back to some other numbers besides 1 and 0. So let's say we have, we'll do negative 6 divided by 27. Okay, well, my first, and you should recognize this by looking at this fraction. The denominator, 27, is a lot larger than the numerator. So what does that mean? That means the denominator cannot go into the numerator. So we can't take 6 things and make a group of 27, right? So if your denominator is larger than your numerator, the best thing to do is to reduce or simplify. Okay? Some people like to give decimals here, but in higher level mathematics, and it depends upon what you're doing. If you're doing science, maybe you want decimals. But in higher level mathematics, we like exact answers, so we leave it as a fraction. So we reduce or simplify. And both these numbers can be reduced by 3 or divided by 3. So 6 divided by 3 is 2. 27 divided by 3 is 9. And we're having negative divided by a positive, so that makes our overall answer negative. Okay? You can just put that negative sign right in front. So for certain division problems, you might have to reduce. Let's look at another example. Let's actually switch that. So let's say we do 27 divided by 6. Now, this is a totally different problem. Some people think, and we'll say we'll just keep them positive for right now. But if let's say this was a positive 6, this is a totally different problem. Division, the order matters. Okay, the order is very, very important. So now, for our multiples of 6, we have 6, 12, 18, 24, 30. So what that means is 6 is not going to go into 27 to be an integer. Okay? So we need to simplify it. And just like before, and it's just, you know, because we flip the numbers around, 3 goes into both of these. So we get 9 over 2. Okay? So now here's an example where the denominator is smaller than the numerator. So going back up here for a second, if the numerator is larger than a denominator, you're definitely going to have to reduce. But sometimes you might just have to look at the problem and by knowing your facts of the denominator, know that it's not going to go into the numerator to be an integer. So therefore you have to simplify. So that's why division gets so tricky sometimes for some students, is they want everything to work out to be an integer, and that's not true. All right? So let's try some practice. Okay, so here are 6 problems I want you to try on your own. So at this point, write these problems down in your notebook or in your notes. Pause the video, and then I'm going to go over them. So the next 20 seconds will be blank, but for you, pause the video and do these problems on your own. Okay, so hopefully you're able to do these problems on your own. So let's go over them. So number 1, we had negative 49, divided by negative 7. Well, 49 divided by 7 is 7, and a negative divided by negative is positive. So our final answer for that one is positive 7. Number 2, 0 divided by negative 20. So if 0 was any other number, this final answer would be negative, but 0 is a neutral number. So 0 divided by anything is just 0. Okay? Now just so you're aware, if that problem was reversed, if it was negative 20 over 0, that would actually be undefined. So if 0 is in the denominator, or the number we're dividing by, it's undefined. Number 3, 44 divided by 4 is 11, and a positive divided by a negative is negative. All right? So now I get some harder problems. Number 4, negative 28 divided by negative 50. So before we do anything, we know a negative divided by negative is positive, so our final answer is positive. But right away, you should kind of get a red alert in your head because the denominator is larger than the numerator. So there's no way on earth this is going to be an integer. We're going to have to simplify. So what you're trying to do is divide both these numbers by the largest number possible. If you look at them, they're both even numbers, so 2 goes into them. Okay, and if you don't use the largest number possible, you can always reduce it again. So 28 divided by 2 is 14, and 50 divided by 2 is 25. Remember, our negative divided by negative was positive, and that's actually our final answer because that can't be simplified any further. Okay? Number 5, negative 1 divided by 10. Well, 10 cannot go into 1. It's actually just like number 4, but that can't be simplified either. So our final answer is negative 1 over 10. And by the way, when you're dividing, if one of your numbers is negative and your answer is a fraction, just make sure overall fraction negative. If they're both negative, like number 4, well, that became a positive, right? You don't have to write the plus there, but that became a positive. So just so you're aware of that. And then finally, number 6, we have negative 100 divided by 12. Well, for your multiples of 12, you have 12, 24, 36, 48, 60, 72, 84, right? 96, and then if you're doing those out, you could kind of see at this point it'd be 108 that 12 does not go into 100 to be an integer. So we're going to have to simplify. So what we're trying to do is determine the biggest number that goes into the numerator and the denominator. I like to try factors of my smaller number because your factors can't be larger than that number itself. if two numbers multiply to be a number. So factors of 12 are 1 and 12, 4 and 3, 2 and 6. I want to find the largest number that goes into 112. It's actually going to be 4. So 100 divided by 4 is 25. 12 divided by 4 is 3. And a negative divided by a positive is negative. So thank you very much for your attention. Hopefully you found this video lesson helpful. If you have any questions, please let me know. Have a fantastic day, everybody.